everybody, it's Miss Prissy again. I'm here to discuss 1.04 number properties, and before your head starts spinning around and trying to explode, I want you to take a deep breath because I know all of you can do this and it's very, very simple. Now, I know that y'all are going to say, well, it might be simple for you, but if you remember, you can pause the video at any time to rewind it and go over it again, or you can pause it to take notes. So here we go. Number properties. The first property we're going to discuss is the identity property. Now, you can color your hair or change your clothes, but whatever you add to yourself, you still say I'm the same person. Our answer still stays the same. So think of it as, no matter what you do to yourself, who you are, your identity, you're the same person underneath all that. So what can you add to not change the value? That is an identity. Under multiplication, what can we multiply by that doesn't change the value? And that would be 1. So that's how you know when it's an identity property. Inverse property means opposite. And so when we talk about addition, the opposite of addition is subtraction. The opposite of subtraction is addition. So it's the opposite property. Now, what we have to be careful with is the opposite of multiplication. I know all of y'all are going, oh, well, that's division. So you have to keep that in mind. When we're multiplying, the opposite is division. And right here, when we multiply by a fraction, that's the same thing as dividing. Okay? So the inverse is the opposite property. Now, what about commutative? I'm sure that y'all have heard of commuters. Commuters go back and forth. They go to their job and then they come back. Like people in DC, they ride the train. They ride the train to their job and then they come back because they commute back and forth. So this means that they change location. Change location. So that means they're going to move. The letters are going to move. See how it's 1 and 2 here and then 2 and 1 here. The letters change position. So 4 plus 5 is the same thing as 5 plus 4. Same way with the multiplication. 4 times 5 is 20, and that's the same thing as 5 times 4. They change positions. So let's talk about associative property. Well, the associative property is the parentheses move. If you notice, the numbers stay in order. 1, 2, 3. Oh, look, it's still 1, 2, 3. But in the first set, the parentheses are with 1 and 2. In the second set, the parentheses are with 2 and 3. So the numbers stay in order, just the parentheses move. Same thing with multiplication. 1, 2, 3. 1, 2, 3. Oh, look at that. Same. Stay in the same order. Now, the distributive property probably is my absolute favorite. Because this little guy, he's the distributor man. He comes over here and gives some to B and gives some to A. So, do you see the distributor right here with the B and the distributor with the C? I call this one, everyone gets the windsock. And you're like, what? Well, I used to live on base in Cherry Point, North Carolina. And they had a paper distributor. That would be this guy right here, Mr. A. And he went to house B and he went to house C. It didn't matter if they wanted the newspaper or not, but they all got the newspaper. And what was the newspaper called? The newspaper was called the Windsock. So the little distributor man goes here and here. Everybody gets a newspaper on the route. So you can't forget the second one. This is the one most people forget. So So the distributive property is everyone gets the windsock. So let's review. Identity property stays the same. Stays the same. Inverse is the opposite. Opposite of addition, opposite of multiplication. Commutative, the numbers change location. Associative, the parentheses move. And the distributive property, everyone gets the windsock. So let's see if we know our properties. Okay, so let's look at our first property. What's going on? We have 2, 3, 8, 2, 3, 8. Oh, well the numbers are in order, but what's going on with the parentheses? The parentheses move. So this is the associative property. And please don't abbreviate it with the first 3 letters. I know you're going, oh, that's cute. Okay, so let's look at the second one. 10 times 15, 15 times 10. The numbers change position. They flip on each side. So this is the commutative property. It's the commutative property of multiplication. Up here, it's the associative property of multiplication. So let's look at the next one. 4 plus negative 4. Okay, so what 4 and negative 4, those are opposites. So this is the inverse property of addition. Okay, the next one. 4 to 7, 4 to A. Oh look, the distributor man is on each of them. Everybody gets the windsock. So this is the distributive property. Now, it is not a distributive property of multiplication or addition because it has both. It's just called the distributor property. Okay, so the next one. 2 plus 5 plus A and A plus 2.5. So what's happening with these guys here? Well, on the left they're one way, on the right they're the other. They switch places. So which property switches places? Which property moves, changes locations? And you're going to say, oh, that is the commutative property. But this time, instead of it being commutative for multiplication, it's commutative for addition. How do you know? There's an add sign. That's how you know. Okay, so the next one is 1 times 3 over 8 equals 3 over 8. So I'm multiplying 3 over 8 by 1. Well, what do I get back when I multiply that? Oh, 3 over 8. So my identity doesn't change. And since it's an identity, multiplication identity. Okay, next one. What is going on? 8, 12, 7, 8, 12, 7. Uh-oh, the numbers are in order. But look at that. This one has the first group together. This one has the last two grouped together. And that, my friends, is the associative property of addition. And how do you know whether it's addition or multiplication? It's going to have addition signs or it's going to have multiplication signs. Okay, the next one. Negative 2. What's the negative 2 doing? Oh, look at that. Everybody gets the windsock. Everybody's getting the paper. So this has to be the distributive property. This is usually the easiest one to see. Okay, next one. You're like, 0.25 times 4 equals 1. You're like, oh, we don't have a property that says that. Oh, but wait, we do. Let's think back. What is 0.25 as a fraction? Oh, it's 1/4. So it's 1/4 times 4. And multiplying by 4th is the same thing as dividing by 4. So the opposite of multiplication is division. So this one is the inverse of multiplication. Okay, last one. 2x and 4. What could it be? What could it be? Well, 2 the x and the 2, and this is the distributive. Okay, so let's talk about closure. This is one of the words that you're going to hear in your lesson. You're not going to use it too often, but you do need to know what it means. And closure does not necessarily mean you in relationships. Closure means that if we have a set of numbers and we do something, if we add them, if we divide them, if we multiply them, will that answer be one of the numbers in our set? Okay? A set is closed under an operation if the result, which means answer, okay, if the result of the operation on any two elements of the set is also an element in the set. Okay, so determine whether each set is closed under the given condition. The set of integers. Okay, so this under addition. So the set of integers. So let's talk. Remember, I'm going to have the little squiggly brackets because that indicates a set. And we'll have dot, dot, dot because we know that it starts somewhere. So -2, -1, 0, 1, 2, dot, dot, dot. Now, those dots mean that it'll go on forever in each direction. Okay, so let's take two of these numbers. Any two. So I'm going to say -2 plus -1. Oh, that's -3. Is that still an integer? And you would say yes. So, since my answer is still an integer, it's still the same type, then this is closed under addition. Now, let's look at integers under division. Okay. Same thing. I'm just taking a little sample. Doesn't have to be these particular numbers. I'm just taking a little sample. So let's pick any two numbers. How about a +1 divided by 2? Oh, well that's 0.5. Is that an integer? Is my answer, my result, an integer? And my answer is no. My answer has to be the same type of number because it has to be in this set. So this is not closed. Think of closed being no numbers in, no numbers out. If you get a different type of number, it can't come in because it's closed. Okay, so let's try natural numbers. Now remember, natural numbers are counting numbers. So I'm going to start 1, 2, 3, 4, 5, dot, dot, dot. And remember, if you get one answer that isn't closed, if you get one answer that doesn't fit, the whole thing is not right. Okay, so let's see. It's under subtraction. So let's do 3 minus 1. 3 minus 1, that's 2. Is that a natural number? You're going to say, yes, that's a natural number. So your logical assumption would be, well, then it's closed because we get the same answer back. Well, what if I did 1 minus 3? Uh-oh, that's a -2. Is -2 a natural number? No, it is not. It is not a natural number. So this is also not closed. And I will give you a hint that generally your sets will not be closed under division and subtraction. Okay, let's talk about this. We're almost done. Now this is 6th, 7th, 8th grade math. I want to point out to you that you have to remember that the big number on powers and exponents, the big number is the base, the little number is the exponent. The big number tells you what to write down. The exponent tells you how many times to write it down. So this is going to be 5 times 5 times 5. which would be 125. Now, I want you to look at these down here at the bottom and say, oh, but what's different about these? Well, what's different is one is in parentheses, one is not. What this says is -5 times -5 times -5, which is -125. What this says is negative 5 times 5 times 5, which is still -125. And you're like, okay, so what's the difference? Well, I'm going to show you the difference. What if I said 2 cubed, well, I'm sorry, -2 cubed. No, I lied. I'm teasing you. I'm teasing you. I meant, what if I did -2 squared and or -2, then the square. Okay? Well, this says -2 times -2, which is +4. But this says negative out front, and the 2 is only on the base. So it'd be 2 times 2, which makes this -4. And you're like, wait a minute, that's not right. And the reason I'm telling you this is because you have to be careful with your calculator. Always, always, always use parentheses when you're using exponents in your calculator, because your calculator will not do it correctly. Okay, last topic, like terms. In order for you to add or subtract, you have to have the same letter and the same exponent. And then you add the coefficient. So you're going, what is a coefficient? Coefficient is the number in front of the letter. A constant is a number without the letter. That's what those are. Okay, so let's see. What's ones are going to be the same? Well, I got an x squared here. Let's put another square. Oh, look at that. Those are going to be the same. And then x and x's are going to be the same. And then look at that poor lonely guy. So if I have -4x squared and a +8x squared, that is going to give me 4x squared. Think of it like if I have 8 apples and I take away 4 apples, I have 4 apples, not 4 half apples. Okay? You don't change the letter in the exponent when you add. You don't change the letter in the exponent when you add. You don't change the letter in the exponent when you add. Okay, just want to make sure you knew that. Okay, so what about the 3x and the 20x? If I have 3 x-ray machines and I owe the bank 20 x-ray machines, uh-oh, gonna have a problem. That means I owe the bank 17 x-ray machines. And what about this -10? He doesn't go with anybody. He's a loner. Okay, so now let's look at the bottom one. 9mn. No exponents. Remember, same letter, same exponent. Same letter, same exponent. Oop. Okay, so those are it. How about mn squared? Mn squared. Okay, so those have mates. How about an m? Oh, look, he's all by himself. And then I've got an n and an n. Okay, so now we've got to do our mn's. 9mn minus 3mn is going to give me 6mn. Remember, we don't change the exponents of the letters. Plus 2mn squared plus 8mn squared gives me 10 of those bad boys. Let's do plus 4m. And then I have minus 4n plus 4n. So this is going to be minus 3n. And that's all she wrote? Okay, your secret word. Your secret word. Where do you write your secret word? We write it on our pace chart. Right on pace chart. Okay. Oh, that's supposed to be pace. That's an E. I got carried away. Write it on your pace chart. Why? So you can prove to me that you watched the video. This one is going to be Buzz Lightyear. Buzz Lightyear. Buzz Lightyear. But I'm not done. I got 2 more slides. Okay. So, in your course, if you open up the lesson, there's a button that says Learning Resources. This is your homework. You should be doing these problems before you take your quiz, because there are no redos, there are no corrections. Sorry. Do your homework, then take the quiz. That's how we do it. And don't let your dog eat your homework. Just make sure you have it all completed before you take your quiz. Okay. Also, remember the closing public service announcement. Don't forget to put your course name and section number with all communication. If your course number will be a 302, 303, or 304, and then or 500, but that's calculus. You'll have one of these, and then you will give me your section number. Okay, thank you very much. See you later.